Welcome to section 7.2. We've split it up into two subsections. The first subsection, we're going to be talking about how to multiply rational expressions. And in the next video, we're going to be talking about how to divide. All right? I'm just going to walk through a couple of examples, but before that, I'm going to explain the method that we'll be using. So in section 7.1, we practiced how to simplify. And we're going to now use this, we're going to build off this principle of simplification, and we're going to figure out how to simplify a product of two rational expressions, right? So what do I mean? I mean, in general terms, I have one rational expression times another rational expression, all right? Notice in the previous example, I had r over r. That was our 1 equals r over r identity. But in this case, r does not equal s. Okay? So what we're saying is that we have two different rational expressions that we're going to multiply. Well, the way that this works is the way that it works for fractions. Okay? Where we had, when I had a fraction, a over b times c over d, we just multiplied the top times the top and the bottom times the bottom. Well, same thing for rational expressions. It's going to be the top expression times the top expression, and then the bottom expression times the bottom. Okay? That's the rule that we're going to use. So let's see it in action. So our first example, quantity 6x plus 6 over 5 times the quantity 10 divided by 36x. Okay. Now we can apply this rule directly, and we'll get 10 times 6x plus 6 over 5 times 36x plus 36. And we'll note right away that 10 and 5 have a common factor of 5. So this reduces down to 2 over 1 times 6x plus 6 over 36x plus 36. But if we look at how far we've gotten so far, we haven't simplified it enough. Even though we just applied the rule here, it may be smarter to start by simplifying our expressions. So why don't we simplify this term? Where we pull out a 6, right? The top terms share a 6. So we can pull that out. 6 times x plus 1 over 5. And I'll go ahead and pull the 2 out of that. And now we note that both of these terms share a 36. X plus 1. Well, by my rule where I can multiply just the top and the bottom, why don't I go ahead and look for things that I can cancel out, or I can reduce to 1. Like the 5 and the 5 I know reduces to 1. 6 and 36 also share a common term of 6. So this reduces to 1, and this reduces to 6. And I also note that x plus 1 and x plus 1 are common factors. So those reduce to 1. And all that's left is 1 over 6. So even though I started with a very complicated product of two rational expressions, when I simplified it, after I multiplied it, I got the very simple 1 over 6.
Isn't that 2 over 6?
Oh, sorry. 2 over 6. Yeah, sometimes it's difficult to see these things. So yeah, I got the 2 here, and I got the 6 here. So what I really have is 2 over 6, which further reduces to 1 over 3. There we go. All right, so let's take a more complicated example. And I'll try to be a little bit more vigilant about identifying things that reduce. So let's see here. And we're going to do one that's just a little bit more complicated. So let's see. X cubed minus 25 over, let's see, oh, that's x squared. Over x squared minus 3x minus 10 times x plus 2. Okay. So before we combine these together, let's apply what we learned in section 7.1. Let's simplify this and see if we can isolate things that we know are going to be common factors before we combine everything together. So this term you might recognize as the difference of squares, right? 5 squared equals 25. So we have a difference of squares here. And our rule for a difference of squares is going to be a plus b. We can rewrite that as a product, right? This is a difference to product. These relationships are very useful. Okay? So let's go ahead and rewrite our first numerator as x plus 5 times x minus 5. And now let's find a way to factor this, turn this from a difference expression into a product expression. We'll use our factoring method. So again, I'm looking for a product of negative 10 times x squared, which is negative 10x squared. Factors of x are x and x. The factors of negative 10 I need to add up to negative 3. And I'll note right away that it is 5 and 2. When I add negative 5 to positive 2, I get negative 3. So let me write that. Let me carry over that. Rewrite my middle term as a sum of negative 5x plus 2x. And then just drop down my negative 10. Drop down my x squared. And now I will group. I have a expression that I can group. I'm going to pull out a common term here, x and x. And I'm left with x minus 5. I'm going to pull a common term out of here, right? These both have 2. So I'll pull out a positive 2, and I'm left with x minus 5. This will always happen if a trinomial is factorable like this. You'll always get a common term when you apply this method. So I note right away both terms share an x minus 5, which means I can pull that out of both terms. And I'm left with the quantity x plus 2. So let's see. I've got x minus 5, x plus 2. And now remember, I'm combining this. I'm multiplying this rational expression. So I have my second fraction. And now that I've got everything simplified, I can isolate and ID and reduce. So I note that I have x plus 2 in the numerator and x plus 2 in the denominator, so those are going to reduce. And I have x minus 5 and x minus 5, so those are going to reduce. And that's it. This is not the same thing as this. So x plus 5, that quantity is not the same as x. So what I'm left with is just x plus 5 over x. Now I do want to make a very important point here. So you might be tempted, so this is the correct answer. Let me go ahead and box it in. But you might be tempted to say, well, the top term has an x in it and the bottom term has an x in it, which means x and x cancel. Right? So this is danger, right? So again, knowing when to stop. You might say, oh, this cancels, therefore all I'm left with is 5. This is not mathematically correct, okay? Because x can represent any number. What we're looking for are common factors of x, not like terms, not common terms. Like x is certainly a common term here, but it's not a common factor in this case. I'll give you an example. What if x equaled 3? All right, and what we've theorized is that we can reduce this to just 5, right? So when I plug in 3 to my equation here, or my simplified expression, what I get is 3 plus 5 divided by 3. Well, that's 8 over 3. Does that equal 5? Nope. Okay? So be careful when you're simplifying. Know when to stop. And you stop when you are finally rid of all of your common factors. You might end up with common terms, but you don't have any more common factors. You've simplified. Okay? So that is a brief rundown of multiplying rational expressions. In the next subsection, we're going to learn the rule for dividing rational expressions.